My name's Jeffrey McGrew, and I run a design-build architecture studio in Oakland, California called BecauseWeCan. We are like a typical architecture firm in a lot of ways. We do the permitting, we do the drawings, we do all the design work, but then we also have an in-house shop with a bunch of these guys and other stuff that we use to make custom things for our own projects. So we not only design the project, we also help build the project, and we fabricate a ton of stuff in-house using a lot of different processes, some manual, some automated. And automation is something that we've been really digging into for like the last decade. It's a big part of our business, and it's how we work. Also, we're finding ourselves more and more getting pulled into projects by much larger engineering teams or architecture teams or like design build contractor teams where we're helping realize part of the project. Because they had the client or the designer or the engineers have some big idea. They vaguely know what it looks like. They don't really know what it looks like. They need somebody to help model it, produce the fabrication, price it, and help get it built. So what I'm here to talk about today is automation. Now, automation is empowering, it's interesting, it's exciting, it's profitable. It's really, I mean, it's been a huge topic at AU this year, but at the same time, automation is terrible. It's expensive, it's difficult, it's fragile, it's disruptive. So, you know, automation is always going to cost some money, it's going to cost a lot of time, and so you have to be sure you're getting the right value back from doing it, right? Lots of examples that I've seen where people have automated some process and haven't really made it better, right? Or they're thinking that if they automate this process or automate this workflow that they're producing better work and they're not, right? So it's all about the created value. And this old XKCD cartoon is a perfect example of this where, you know, it's like trying to automate some process by writing code and then it's like, you know, the ideal is that the automation takes over and your life is awesome. The reality is that you never finish the automation project because things keep changing. So what I'd like to talk about today is some tools on how to think about automation. So when you guys are going to automate stuff, you can do it in a way where you're not wasting a ton of time and you're not wasting a ton of money, right? My company is tiny. We don't have a lot of people. We don't have a lot of money. So we've had to be really careful about how we go about these things. So in what we've been doing with our automation, we've noticed that the different types of tasks that we're automating tend to fall into one of four categories here, right? And so I'm going to talk about this a little bit, and I'm going to talk about some general ideas that are good to have in mind when you're automating stuff so that you can be really effective at it. And then the last part, I'm going to talk about more about like how to future-proof yourself a little bit and how to make it to where you'll be able to leverage your skills further into the future via automation. Like there's a lot of like really false assumptions, like who here actually works with like CNC fabrication, driven fabrication right now, right? All right, so like a lot of the hyperbole of a lot of the presentations at Autodesk University about how robots are going to take over the world, if you actually work with robots, you know that this is fundamentally not true anytime soon. So at any rate, the first one is something we call same job, only cheaper, all right? So this is where you're taking some task that was done by a person before and you're automating it, and you're doing it purely because by automating it, it's cheaper than the person doing it, and that's it, right? The automation isn't going to do the task better. It's not going to make the task easier. It's not going to like radically change your whole business model. It's just literally a pure economic one-to-one kind of thing, right? So you're freeing somebody up so they can do a higher value thing than some grunt work thing that they were doing before, or, you know, hopefully not, but you might be just replacing somebody outright. You know, like, oh, we don't need a person to do this job anymore because we can automate stuff. So in this instance, because it's such an economic equation, it's really all about, you know, setup and maintenance costs are really important to keep under control. Whatever's the cheapest and easiest thing to build and maintain is going to be great. So like theoretically, sure, writing like C# code and making your own add-ons for Revit or something like that is awesome. But if you can do it easier, you should do it easier, right? And it's only worth the cost if it's used and managed correctly. Like cheaper actually has to be cheaper. And we'll talk more about that with some metrics and stuff later. So a great example of this is just basic scripting. Like who here is already using basic scripting of one kind or another, right? Yeah, like everybody, right? So I'm talking about like Dynamo and Lisp of old and like just where you're automating some repetitive task, right? So this is a kind of an example from the design side where we're taking something like room renumbering, or we're taking like, oh, I want to make some crazy form that follows certain rules or something. And all we're doing is making it, you know, a person could easily do these things. It's just that we're doing it a little faster, a little cheaper because we're automating it. And it's not really doing that much of a better job. Like I can still screw up the room renumbering, the room renumbering if I, garbage in, garbage out sort of thing, right? Like if I start that process wrong, it's going to come out wrong. And there isn't really a lot of difference between a person doing it versus a script, other than the script could be faster, right? An example for the more like on the physical side of this type of automation is automated saw stops. Who here has seen one of these things before? They're actually pretty cool. All right, cool, yeah, it's a couple people. So it's basically a little Android tablet here. You walk up to you punch in the length that you want to cut, and this little automated fence moves to that length for you automatically. You put your part in, you chop it, right? And that little tablet can tie into your bill of materials, can tie into your CAD models, all this sort of stuff. But again, like any skilled fabricator could move the fence, set up for cuts. Like it just makes that job a little faster, but it's really not, like you can still cut it wrong. It's not really adding that much value other than just, it might be cheaper to cut stuff this way than some other way, right? The second type of automation that we get into, that we found when we go to automate tasks, is something that we call automation does it better, right? And so this is where automation not only can do the job maybe cheaper, or maybe it can't do the job cheaper. Maybe the automated solution that you have isn't cheaper than having a person do it, but it winds up being a better end result, right? So here, instead of it being just a pure economics, like what's the cheapest way we can go about doing this, now it's getting it right is more about fully and truly understanding the nature of the task and the workflow itself than the technology. Because I'm sure you've seen lots of instances where somebody like automated something that a skilled craftsperson could do in like half the time, right? And so it's really not any better than the skilled craftsperson. Also, with this kind of automation, when you're automating something that you hope to be better, it's easy to fall down rabbit holes and waste lots of time by focusing on the wrong things, right? Like a great example of this is, we did this whole lean manufacturing study for our shop, and we kind of determined like, oh, if we bought this fancier CNC router that's faster than the existing old one that we have, all it's going to do is make a bigger pile of parts waiting for the next person to sand them. Like, it's really not going to actually increase any of our throughput at all, right? So theoretically, while that's a better machine, it's not actually making the overall process better at all. And so a great example, like a real-world example of this, is some of the like kind of direct-to-fab stuff that's going on. I'm not saying that these workflows are ideal at all. They're a mess, right? Like there's a lot of garbage here. There's a lot of hype. There's a lot of problems. There's no standards in the digital fabrication world. Like imagine the web where HTML never happened, right? Or desktop publishing where PDF was never invented, right? Like the code for one machine won't talk to another machine. And but the fact is, though, is that models driving the shop drawings, the bill of materials, and even direct to fab, right, can be, if you set it up right, a fundamentally better way to work than the old way, right? So who here is already working in like structural steel or like sheet metal ducting or that sort of stuff? Whoa, nobody. Wow, okay, well, one person, okay. So while all the architects have been endlessly talking about robots taking over the world, in a lot of the subs, they have, right? Like a lot of structural steel now is just made by automated digital fabrication, and a lot of it's direct-to-fab stuff. Same thing with HVAC. Most millwork, and this is more in my wheelhouse since we make a lot of furniture and built-ins and stuff for our projects, a lot of that is heavily automated now to where nobody's actually, all the parts for that cabinet are getting cut out by CNC machines that are getting that driven from a model somewhere, and you're making very little shop drawings along the way. But the problem here is that, like I was saying before, the data workflows can be really complex, lots of proprietary snafus, setup time, tooling costs, lots of like manual fussy little things that you got to do. And the robots can quickly make a whole lot of the wrong thing just as quickly as they make a whole lot of the right thing. So that's why, it's a better workflow, but it's not really making things easier yet. So this is an example from my firm of a project we're in the middle of right now, where we're helping design and make this crazy ceiling for this like really high-end house that's down Palo Alto area. And so it's like slat wood, like ribs of wood. And then every so often the ribs are actually sanded acrylic that's backlit that makes the lighting for the house, And they wanted, we pitched this design idea where there'd be these like undulating negative surfaces, carved out of those ribs. And it's not just that those ribs oh, that picture's really dark. Crap. All right, well, I'll try to explain. These ribs aren't just 2D cutouts. They're actually 3D carved. Like the top of every rib is actually shaped and tapered to match that thing that's being driven by the CAD model. So we have in Fusion a big T-spline based thing for that whole ceiling, right? And then we're breaking it down into 4x8 panels, and then each rib is getting CNC carved off a blank that we're making that's going in the CNC router. And we're able to have these be numbered. And so like theoretically, a really good woodworker craftsperson could do these kinds of carvings, but we're able to do it a lot better because they all fit together perfectly on the job site and everything like that. But it's still a huge amount of work, and it's complex. So there's just another shot because the ceiling runs all the way through the house. So you'll actually see like whatever undulation pattern the client finally decides on, where we've been going back and forth for a while to try to figure it out. You'll be able to see it run all the way through the house from room to room, right? So just kind of showing a real-world example of something we're in the middle of right now. Because the next type of automation is what we call automation makes it easy, right? And this is where it's not just that it might not be that it makes it cheaper, it might not be that it makes it better, it's that by automating something, we're just making that whole process a lot easier to do, okay? And here, the focus really needs to be on empowerment. So if what you're trying to automate is a task where you're automating this thing to make it easier for everybody to do some complex thing, you don't care if it's cheap, you don't want to maybe do that in the cheapest way you possibly can, right? You might not want to do that where you need to focus heavily on like exactly what the tasks are that people are going to do. You want to keep people, it's more about like, what can we do to keep people doing the good things that they're good at, and what can we do, what can we delegate to the automation or the robots to do instead? And one of the examples that I love from this is, there's a fairly recent term, and it's a little pretentious, but there's this term that's going around like the Silicon Valley area where I'm from that they're calling centaurs, right? Where it's like there's some human at the top of a whole lot of automation underneath them that's empowering them to be able to make like better decisions or like better work or what have you. A great example of this is who in this room has had laser eye surgery? Right? So when you have laser eye surgery, there is a very skilled surgeon working with a very special robot to shoot lasers in your eye to fix your eye, right? So, this is something where theoretically they might have been able to do it before, but because of the automation, the whole process is made easy, and it's more about collaboration. So when you're automating tasks that fall into this category, you really need to focus more on like the user experience, right? Like if you're automating something just because it's cheaper to automate it, nobody really cares if it's crappy to work with. Like if you have some terrible UI. Like that saw stop, tiger stop thing, nobody cares if the little Android tablet looks nice with the UI that they're working with, right? They just care that they can punch numbers in and get the length that they need. Here, it's way more about making something so that the tools themselves can empower the people that are working with them. And a great example of this is a lot of the stuff that you see in generative design we feel kind of falls into this category, right? Where you're going to take some process that would be really difficult to do before, and by automating certain parts of it, you're going to make it easy. So like, this whole idea where you're going to like generate, maybe 50,000 variations or 1 million variations of some part, and then do some kind of assessment thing to figure out like what's the final thing that you want to do, is a great example where the automation is making this process easy, right? You could have done this before, but automation is empowering people to make it a lot easier to do. And that's the thing, well, we'll get to that in a moment, sorry. So like things like Project Fractal and Dreamcatcher and Dynamo and all this, so rule-driven, goal-driven sort of modeling sorts of stuff, we feel kind of falls into this category. And this is some work that we've been doing over the last couple of years where we made a series of nodes for Dynamo that we call Because We Dynamo. That's all about fabrication tasks, right? So it does like part labeling and edge labeling and exporting. And so with this, we're able to make like a Dynamo routine here that you feed it any standard mesh, as long as all the faces are flat, it gives you back all the panels and connectors and parts ready to cut out on a CNC router, labeled, with numbers of where they go. So this one's labeled for where it goes, and they key into each other, so you can't screw it up, right? Like this is always going to be like orthogonal to where it needs to be, and you screw it together, sort of stuff. And so it makes it really, really easy. Like, we cranked this out in like less than a week just for like a local design show, because we were like, oh, we don't have anything. Let's just make something. And it's like, 3 days later, we've got a thing. So, and we've used it to do like these crazy seating units for a commercial office, like co-working space that we did in Oakland, where they wanted these like icebergy sort of like weird landscape of seating things. And so we were able to just do this really easily. So this is all about, using the automation to make it easy to do. So, and this is all on GitHub. It's all open source. You guys can mess around with it. I haven't had time to update it. It's still on an older version of Dynamo because, again, we're tiny and we don't have a lot of money. So, and then Dynamo kind of changed underneath us, and now we're like, crap, what are we going to do? There's more seats up here if you guys want to not stand. There's some empty seats that you're more than welcome to come in and crash. There's a couple up front here. There's a couple over here. There's a couple over there. Yeah. Not that you can totally stand if you want to stand. I just so. Well, and the other thing too to focus here is we're not making any shop drawings of any of this stuff, right? Like, these self-assemble almost. You make all the panels, you make all the connectors, you start screwing stuff together, you wind up with your crazy thing. Like, there's no drawings. As a matter of fact, these crazy icebergy forms, we would just put Joel, one of our fabricators up there in that picture, we would just have him with a screw gun inside of it, and we'd make the base layer, and then we'd just bring him panels, and he'd screw the panels on. He'd just wind up entombed inside of them, and then we'd like lift them up, and he'd crawl out, and we'd set it aside, and we'd start building the next one. Like, because it was literally just like, oh, we need panel 206, okay, panel 206, and it like, sort of thing. It can only fit in one way. It's obvious which way it goes, So again, it's like using automation to make something really easy. And it's not like these are like hard and fast types, like something only falls into one. It's just when you're trying to automate different tasks in different ways, it's really important to focus on what's important so you're not wasting a ton of time and energy. And we've just found that with these 4 categories, it's helped us at our thinking in terms of how we navigate through that. The last type of automation is something that we call, automation makes it even possible, right? And so what this is it's kind of the hardest to pull off, honestly, but it's very systematic and holistic, and whole businesses tend to shift to be able to use it. Like when CAD first got adopted by the industry, and now with BIM being adopted by the industry, there's that old, adage where they're like, oh, you have to fundamentally change your business to be able to leverage this technology, right? It's that kind of thing. So, and the problem with this is just because it's now possible doesn't mean it's actually valuable. And coming from somebody who makes crazy things for a living, that's a little egregious. But seriously, like, just because you can automate something now doesn't necessarily mean that it's a good idea, right? If you have to shift and change your whole business to be able to really leverage it. But a couple of real-world examples from this. One of them is ConnectX. They're actually down on the show floor. The steel, like, second-story structure thing. Who here saw that? I'm hoping a lot of people did. Yeah, they're from Hayward. They're brilliant. They basically developed this really clever system where this is like a dovetail joint, where this piece here and this is welded to the column, this is welded to your beam. It slots like that, and then bolts go in, and now you have a moment frame, right? And all of this is getting made by giant automated machines. Like, none of this would be possible without lots of automation in the mix, right? It also fundamentally changes the way that you can deliver structural steel, right? And they're having to ConnectX. One of the things that they're struggling with is that their value proposition is really great, but like, the contractors are just like, oh, we want the steel for as cheap as we can get it. We don't care that what you're producing is like sub-millimeter accuracy and goes up in like a week as opposed to like months, right? We just care that the steel bid is low. Where the owner's like, oh, heck no, I totally want something that's sub-millimeter accuracy and goes up in a week. That's awesome, right? So, but what I'm saying is like the whole business has to be aligned to make use of this sort of stuff. And so this is what we kind of call this type for automation. And you have to be careful. And this is the whole, like, just because you can automate it means that it might not make sense. Like, in order to produce these things, they have an entire automated CNC production line with a turreting-like system with tombstones. Does anybody know what I'm talking about? Right? So it's basically, it's a palleting system where you take like the castings that they get, they bolt onto a thing, that goes into a track, that track goes into one of 3 giant CNC mills, that's just whichever one's available grabs it, and then does the processing that it needs on it and spits it out the other end. right? So like huge amount of automation to be able to effectively and affordably make those little joints, right? And so like if you were a traditional steel fabricator, you might be able to make those kinds of joints, but if you're not gonna like radically change your whole business to be based off of that, it might not actually make any sense for you to do that, right? So, and I see this happen a lot on the design side in like architecture firms, where people will get really excited about automating stuff like via Dynamo, and then they'll automate something that, like, sure, it's cool, but they'd have to like radically change their whole business and what they're offering to their clients in order to actually make any money off of it. And so they're really just kind of wasting their time, you know? Another great example, I think, from this world, more on the design side, is some of the stuff that WeWork is doing. So is there anybody from WeWork in the room? No, oh, okay. Well, great, I can talk smack. So WeWork is their co-working company. So what they do is they offer office space. You just pay for it like a gym membership, and you can have like different, whatever you need in terms of office stuff. So they'll come in and they'll rent whole floors of skyscrapers, gut them and build them out into new office space. And because they're also then operating that office space, you literally like, you know, it's almost like a Uber Lyft sort of thing. Like if you need to book a conference room, you just pull your phone out and you book the conference room with your phone, and now they know you booked that room, how long you were in there. You can rate whether you liked it or not after you're done, you know. And they're using all of that to feed back into their design processes. So they have stuff where they're doing like, you know, automated layout of office spaces and automation on the fabrication side too, because a lot of these offices they're making using aluminum curtain wall systems. And they're trying to make it to where some of this can inform the fabrication downstream of all the stuff that they're making and that. But again, like, you know, Gensler, who I used to work for a long time ago, couldn't do this, right? Like, in order to do this, they have to also operate the spaces that they're in, okay? So even though you could automate delivery of office space to people at this level, you'd have to also be the person who's renting the space to your users in order to do it. You couldn't just do this as like a service provider, right? So last example, just real quick, is my company. Everything we do is based off of digital fabrication and automation. So this is a project that we did in San Francisco where we were the architects, but then we also physically made a bunch of stuff for the project. And this cabinet here that's under this existing spiral staircase, you know, we laser scanned that staircase. We modeled everything in Revit to fit. And we do a lot of just Revit to fab, like just straight Revit models straight into fabrication. So we model this to a fabrication level of detail in Revit. All these pie wedge shaped cabinets get made in our shop. And there was a single drawing that we had that showed what order we needed to put them in to put them on site. So this whole, no shop drawings, just model to fab, right? And because of that, we can do this sort of stuff a lot cheaper, and we can make a lot more interesting things for much better budgets than what you traditionally would. And there's no back and forth with like arguing with a millwork sub because they screwed something up and we have to figure out whose fault it is, and maybe we have to like threaten to sue each other, and the client meanwhile is just getting angrier because like it's not getting fixed and it's not what they wanted, and like instead we can just fix it, right? So, but you know, we wouldn't be able to do this if we weren't accepting more risk as a design build firm than a traditional architecture would, right? Like there's no reason a traditional architect couldn't model something this level and scan this thing, but if they don't actually produce it in-house, like it's meaningless, right, for them to do that. So, and the example up top there, same thing. Like that's a shop drawing in Revit to parts to the thing. You know, that top left, that is the shop drawing for that project. Like that's what we showed the client for them to sign off on the design, and then we just went and made the thing. Right? So again, it's this kind of type 4 automation. So when you're automating something, there's a couple just general tips that you can follow that will help you out a lot and make things work a little better that I'm going to get into next. So it doesn't really matter what type of thing you're automating. These are kind of universal. And one of them is this idea. So I had a professor that used to be like a right-hand guy for Buckminster Fuller, and he was like this industrial designer guy, and he was really harped about this a lot. So, you know, automation is just a tool, right? And when you're designing a tool, there's this idea that you have the handle, the body, and the tip, right? So the handle is the part that faces the person that they're interacting with. The body is the middle part that's actually maybe doing the work or supporting whatever, and the tip is the part that's interacting whatever the work is itself, right? Like the most basic example is like a screwdriver. You have a handle, you have a shaft, and you have like whatever the tip is that's turning the screws, right? And so the reason that you might want to break it down this way is that depending on what it is that you're trying to automate, like if we're automating something where it's just purely about making it cheaper and easier, then we want to make the body of that tool out of just anything we can pick up and use, right? Like like I was saying before, like who cares if you're gonna, you know, it's theoretically better for you to write C# code and make a full add-on to Revit when you can just do the same thing in Dynamo, and it might just be project specific, right? So you're just gonna do it for this project, next project you might do something different, so it doesn't even matter to go into some really robust thing. Whereas if it's a business like mine, like the body part, like we have some Revit plugins that we've made to help with our automated fabrication stuff, that it's really important that those things work and that they work all the time and that they don't mess up, you know, and that our workflow works really well, because otherwise we'll have a giant pile of plywood parts that we can't put together anymore and we're gonna eat it because we're on the hook, right? So, whereas other things like that whole automation makes it easy, like generative design sorts of stuff, you might really need to focus on the handle part, right? Like, how's this interacting with my designers? How's this interacting with my engineers? How are they getting the information they need visually so that they can make the decisions that they need to make to be able to do good work? Because, like, I mean, all of those generative design examples that you've seen here at AU, at the end of the day, somebody's looking at all that data and being like, yeah, we should go with that one, right? So how can you make that process easier? And it might, the tip, how it's interacting with the data could be super messy, right? It could be like, all right, it just dumps out a ton of text files into a folder and it's parsing that and we don't care, right? You know, so just, you know, it's a way to kind of break it down and think about it. The other thing that's really important is measuring and metrics, right? So if automation is expensive and can be difficult and problematic, we need to be certain that we're getting the most value out of it, and one of the ways we can do that is by measuring stuff. And so like that example that I was saying before, where if we bought a fancier CNC router, it would just cut things out faster. It would just mean a bigger pile of stuff somewhere, right? So like we could buy the fancier CNC router and look at our numbers of like how many parts we're producing per day and think we're doing great, even though we're not, right? And so one of the things that is really great is something called a cohort metric, which is something that they use a lot in like the software industry, where you're always, you're never looking at a metric just in isolation, solo by itself. You're always looking at it as it compares to something else, right? So like it might be that we speed up our shop time, but we also speed up our callback, right? So like our shop becomes more productive, but we're getting more errors coming through at the same time because we changed something. And now we're like, our clients aren't as happy and we're having to come back and fix stuff more often, and so we're really not actually getting ahead on what we're trying to do. So I'm just basically, sorry to harp so much on this, but because like, you know, even a halfway decent CNC router costs like $30,000, which isn't that much, but it's enough, right? And that's like entry sort of stuff. Like some of these machines, like the ConnectX guys have that whole automated setup that I was talking about with the mills and stuff. I mean, that's probably like, they're probably into that $1 million, you know, maybe $500,000. Like it's crazy. And it lets them do amazing stuff very quickly, but it's gotta pay for itself, right? So, you know, so you gotta like keep track. So putting in some, like deciding at the beginning what the goals are for the automation and then actually keeping track. Like, did your Dynamo script that renumber all the rooms actually save you that much time on the project? You know, like it probably did, maybe once, you know, but like part of the reason that ceiling project that I showed you guys, we used T-splines to do the modeling of the crazy undulated stuff, is we knew the client changes his mind a lot and really wants to be heavily involved in the design process. He's really passionate about it. We know that we're gonna be we've already given him like 7 or 8 different iterations of that design, which is great. Like we're more than happy to do that, but we knew going into it that we were gonna have to do it that way. So we built a system where we could easily change that ceiling. And I can show you guys after the talk, because this talk's not on T-splines or Fusion or anything, but I can show you later like how easy it is that you can like change that surface and then all the downstream processes reapply themselves, and we can do that almost all the way to fabrication, right? So the client can literally make up their mind at the last moment, it's still okay, right? So lastly, there's this technology, this term from the software industry called technical debt, tech debt. Who's heard this term before? Oh, a few people. Oh, this is great then. Okay. So when you're building technology, you always have to make compromises along the way that you might have to deal with in the future, right? So one way that the software industry deals with this problem is they think of it as a debt, right? So like today, let's say I need a CNC router. I can buy a cheap one that's this, right? Or I can buy an expensive one that's twice as fast for this, right? if I'm anticipating that at some point in the future, my needs are gonna get to where I need the faster router, that price difference between those two, I can look at it as a debt that I have because I'm gonna have to pay that off before I can upgrade to that point, right? And so tech debt is something where, you know, it helps you make value judgments if it's worth upgrading or migrating some automated solution to another thing, right? Like there's plenty of people out there that are still using AutoCAD because the AutoCAD has some automated solution that they have for like producing ductwork or something that's awesome. It's paid for, works really well, it's really fast. And if you actually, you know, look at it, it would be a huge cost to upgrade that to Revit for like no good reason, right? And so this idea of tech debt, so when you're making these decisions, when you're automating stuff and you're thinking about what you're automating, it's always good to like at least do like some opportunity cost sort of calculations, or if you can actually calculate what's the technical debt you're incurring. Like I was just saying before, because we based that tool chain thing that I showed you where we're making the crazy forms off of Dynamo, and then Dynamo changed out from under us, right, because it's still developing. Had we done that on like Grasshopper instead, which is more stable, we wouldn't have this debt that we have to pay off now to upgrade to the latest thing, right? So this decision that we made, that we willingly made, because we wanted to base it off of Dynamo because we're working a lot in Revit and it's easier for us to do it that way, and because I don't like Rhino. Don't take it personally, I just don't really care for it. It's just a way that you can actually put a financial number on some of those decisions that you're making. So second to last, I want to talk about some just larger issues regarding automation. So this whole week at IU, you've been hearing about how awesome automation is, right? So I wanted to talk about some of the realities from somebody who's been working with automation for a while. One of them is automation is fragile, right? Trading efficiency for redundancy is a great deal up until everything stops working because a single thing was out of place, right? So a single wire, a single thing is wrong, and all of a sudden your whole tool chain can stop working, right? Whereas that's not true with people. People can always like find something else to do, right? They can always be like, oh, or come up with a clever solution for something, and sometimes that clever solution will add value back in, right? So this idea that you're gonna like automate people out of the picture, I think is actually a foolish one for a lot of tasks because like people are awesome, right? And automation is not. Automation breaks constantly. Like most robots, CNC machines, all that kind of stuff, they're held together by the sheer will of their maintainers and like thousands of zip ties. Like if the robots try to take over, somebody just needs to invent like cutters that cut zip ties or like some kind of virus that breaks down the plastic of the zip ties and all the robots will just stop working. Like I'm serious. Like anybody who works with industrial automation knows that the robots are way more fragile than most people realize. A friend of mine runs a robot event in San Francisco. That's like this world-class event where everybody brings their robot and they do like robot fighting and robot competitions where they have to like climb walls and do all this really advanced stuff. A third of the robots show up to the show DOA just from shipping. Like just shipping them there causes a third of them to break in some way, right? So another thing is automation is stupid. She is awesome. I don't know if you've seen her YouTube videos. She just makes really weird robots for fun, right? And they're great. But fundamentally, like, robots are really dumb. Like the big robot arms that we got in our shop now, they don't know where I'm standing. They could kill me. Like, and like I said before, like our CNC router will gleefully cut thousands of the wrong thing, right? Like, so this idea that like, you can solve problems with automation. If your problem isn't actually something that is related to automation, it's more of like a cultural problem within your office, adding more technology isn't gonna really help, right? Because it's dumb. Like it's fundamentally dumb. Another problem is automation is boring, right? This is a great example. So when people start talking about how like generative design is gonna take over the fashion industry, I'm just like, okay, you just don't understand the fashion industry. Because that's like, so people care about the things that people do, right? People don't care very much about what robots do. When we first started our company, we were like, oh, it's all made by robots, woo, and our clients were like, we don't care. Right? So this is Mozart back in the day wrote a game as a parlor game. It was kind of just a little trick where you roll dice, you follow rules, and it writes a waltz, right? So it's generative waltzes, right? Any first-year computer science, any beginner computer programmer can write a program that can make more waltzes than you can listen to in your lifetime, and nobody cares at all about any of these waltzes, right? There's no spot waltzify that we listen to on our phones, like literally, like we care about the music other people do, right? So robots, automation, it's boring, right? Like, so it's still fundamentally about people. And like I was saying before with the example of all the generative design stuff, they show all this wowie automation with the generative design, but at the end of the day, somebody's boss is probably going like, I like that one. Like, and it's arbitrary. Like, it just negates that whole crazy thing that they did to generate the 5 best option when the boss or the client is like, I like that one for reasons I can't explain, right? The last, another thing is that there's all this talk about how we architects, we in the construction industry are gonna start making things the way Tesla makes cars, which I say is not true, right? Buildings aren't cars. I know this sounds really glib, but like cars and airplanes are, you know, mass-produced objects that are completely made of custom parts, right? Like all the parts that go into that Tesla are for that model of Tesla, right? But the Tesla itself is a mass-produced item, right? Buildings are the opposite. Off-the-shelf stuff, manipulated somewhat, going together into a totally custom thing that's a one-off thing that's the only one that exists in one spot. It's totally opposite, right? So if we just look at this world for ideas of how to automate our world, it's not gonna work. Like, automation in our world is gonna look very different from what we're seeing on the manufacturing side, even though the overall story is like, oh, you know, manufacturing has gotten way more efficient and construction hasn't gotten more efficient, you know, like so we should copy them. And I'm like, I don't think that's really true. Part of that is because of this. This is just this goofy chart that I use. So I believe a building is a result of these 4 sometimes conflicting forces that come together, right? And if we're just focusing on the design side or on the engineering performance side, we're leaving out like, you know, 3/4 or half of the problem of what we're actually trying to solve. So, you know, something has to really touch on all 4 circles to make a really big difference. Like, who's seen this project back in San Francisco? Right, yeah. All right, yeah. So SF MoMA, right? New SF MoMA. The outside skin done by these awesome guys, Chrysler and Associates. They're a fantastic company based out of American Canyon up around Napa. They do big composite fabrication, right? The story you think here is, oh, look, you know, there's the Rhino model and it's all generative and it's feeding this giant CNC router that they have that's the size of this room and it's carving out foam blocks and then they're making all these panels and hanging them and they all fit together perfect. The real story of this project is that Bill Chrysler, the guy who owns Chrysler and Associates, spent 7 years, I think it was, somebody correct me if they know better, fighting the building code people and getting all the UL testing done so that they could use FRP in this kind of an application, right? It was all political, right? And sure, the FRP, like this was originally, I think they were gonna do it out of precast concrete and it would have taken like 3 times more steel and would have cost way more money. The fact that it's all FRP makes it to where these panels could be as long as they could ship them on a truck and are way lighter. And so, you know, there's all this like performance benefit and there's all this talk about the automation, but the reality is that this couldn't have happened without all of this like years of cultural, political work, of all this legwork to get the code to allow them to build using FRP because of the flame spread and all of that kind of stuff, right? But nobody really talks about that very much. Okay, how are we doing on time? Great. Last, strategies for surviving automation. So automation is disruptive, and there are parts of it that are probably coming for your job, right? And so I want to talk about some of the things that you can do that are going to help in the future to keep you from just getting replaced, right? And one of them is empowerment versus disempowerment. And the glib way to say this, although it's not exactly true, it's a little intellectually dishonest, but do you tell the robots what to do or do the robots tell you what to do, right? But the bigger issue is really, are you empowered? So like people are like, oh, like, you know, Lyft drivers, Uber drivers are getting disempowered because robots tell them what to do. But I know people that drive for Lyft and Uber that feel like they're empowered because they can kind of work whenever they want and then spend their time doing other things instead, right? Like I know somebody she's starting her own business doing like this liqueur thing that she likes, and she's driving for Lyft in the Bay Area sometimes to make money while she's like doing her entrepreneurial thing to get her business off the ground. Because she can literally turn her phone on, go drive for a couple hours, come back, work on her next thing, you know. So the question is, are you getting empowered by the automation or disempowered by the automation, right? Like you really want to be on this side of the equation and not on that side of the equation, okay? So for example, another great example is, so I run a small business, there's 6 of us, right? And most of the subs that you're working with, like the plumbing guy, the HVAC guy, those sorts of guys, if they bought a robot to help them do their job, they're just gonna make more money. Like if I automate something, it just makes more money for me and my team, right? It's great. Like this is great because like small businesses can leverage this stuff a lot more effectively, whereas if it's a really big business, they might automate something and all of a sudden don't need like a lot of people, right? And again, this gets back to the idea of centaurs, which is a cheesy term, but it's this term from Silicon Valley where like even when automation gets to the point where it's super smart and can do all kinds of stuff, I believe if you focus more on how can you empower people to do bigger and better things, you'll make more money in the long term than trying to figure out how to just replace people altogether. Another one is wicked problems, right? So a wicked problem is a problem that is difficult or impossible to solve because of incomplete, contradictory, or changing requirements that are often difficult to recognize up front, okay? So recently they made a machine learning program that can play Go at a grandmaster level, right? And they did it because they basically had it play against itself for millions of years worth of like real time, that they were able to do over weeks of computer time. And it was able to train itself to become a grandmaster level Go player. And it plays Go in a way no humans ever played before, right? So the grandmasters of Go are like, this is incredible. We have a new opponent that's an alien, right? Like literally. But that was possible because Go, the rules of Go don't change. It's not Calvin ball, right? Like it's not, like it could measure success in a really straightforward way, whether how well did I win the game and how many moves or whatever versus not, right? If you're dealing with like design, engineering, these sorts of problems, the rules can change, right? You can be like, oh, you know what, we're just like, what if we didn't do this? What if we did this other thing instead? And it changes the whole problem. And so wicked problems are the kinds of things that like machine learning, A/B testing, and all this stuff that they've been talking about at this conference are just not very good at trying to solve, right? Like you can't A/B test your way into making like the next iPhone, right? Do people know what A/B testing is? I'm sorry. Yeah, okay, so A/B testing is this thing that they do in the software industry where like if you come to my web page, you see this page or you see that page, and I track which one people like more, right? And then I'm like, okay, people like this one more, so I'm gonna take that and make 2 more variations of that and see which one more they like more of that, and just keep drilling down and drilling down and drilling down. But the problem is that there's never a moment where you might take a big step back and be like, well, what if we actually did this thing over here instead, and people love that way more, right? So, focusing more on these kind of wicked problems is something that's really valuable. And the last thing is if you focus on, okay, so when it becomes trivially easy in our bright future of 3D printing and automated whatnot to make anything, right, to make anything you want, what still has value, right? Like if anybody can produce almost anything, producing stuff doesn't become that big of a deal, right? Like it used to be making cabinets was hard. Now with all the CNC stuff, cabinets are really easy to make, and cabinets are super cheap, right? Like I can order them from China. We don't make cabinets because there's no way that we could possibly be competitive making cabinets. So our value instead is in these like soft skills. Like robots don't buy things. Like robots don't buy things, people buy things, right? Robots don't have some larger agenda that they're trying to solve. People care about other people and themselves the most, right? So if you focus on what people want and how to provide it, you're gonna be a lot better off on the long term than focusing on the technology or focusing on the automation side of things. So it's great to have automation skills, but if you add that to some other thing, right? Like I'm gonna learn more about designing holistic systems, right? Like back home in the Bay Area, this whole DevOps idea is like all the rage, right? Where you're not just a software programmer, you understand how to write everything from the application to the database that's running underneath it and the whole stack, right? Sales, marketing, personal relationships, right? Like you could be brilliant at automation, but if you're a jerk, nobody wants to work with you, right? Like I know this sounds really trite, but it's really true that like coming back to some of these, or like focusing on some of the humanities and cultural understandings, right? Like you could have the best, fully automated solution for North America that will fail when you try to go to Australia because they don't care about the same things that we care about here, right? So adding these sorts of skills onto the technical stuff you already do is going to help you stay relevant well into the future and not have to worry so much about getting replaced. Because like, for example, my firm is 6 people. We don't have any drafts people. It's all Revit from the day one. It's been all Revit, all BIM. I have no drafts people. I don't need drafts people, right? I have fabricators that have great skills in the shop that are better craftspeople than I am, but they're looking at the same models. We're not making shop drawings anymore at all, We're not making, like we might make some assembly drawings and that's it. We make the least amount of drawings we have to. We make just enough drawings to get the building permit, and that's it, right? So, but if somebody's awesome to work with, and because we're a tiny company, and if they have some great skills in like working with our clients and things like that, I hire them. I'd love to work with them, right? So, and that's pretty much it. I've got plenty of time for questions. I can show more. We can talk more about case studies and examples. Thank you guys for your time so much this morning. I know it's the last day of the conference. And any questions? We got like 10 minutes or so that we can talk. Nope. Oh, all right, over here. Yeah.
I heard a lot of classes about fabrication and using automation in design, less in putting together these two words in something on the side.
Right, right. So his question was to say some more words about, you know, there's all this talk about automation and all this talk about digital fabrication, but not a lot of talk about how you assemble all these things together. In our case, in our little world, we're designing stuff in Revit, and we try to design it, the way that we put it is we try to design stuff that wants to get built. Like the joke that we make is if we put all the parts in a box and shook the box long enough, we'd wind up with the thing, right? So we do a lot of stuff where like the tabs can only go one way, right? This part can only fit into that part one way. And you're able to do that upstream in your design authorization stuff, in your design authoring stuff, so that when it goes downstream into your automated processes, you're making parts that have more value than just being like rectangles that you have to screw together. Like if we're making more like cabinety sort of built-in sorts of things, we're doing all kinds of like little joinery that helps make that better. And some of that is the actual craft. So there's a lot of talk about digital fabrication and automation that leaves out the fact that somewhere along that way, there's like a really talented craftsperson who has learned the craft of working with digital fabrication. It's as much of a craft as like being a really good welder or something. And you know all these like little tips and tricks that you have to do. Like a great example as well is like we don't order a bunch of plywood and wait for the plywood to show up and then measure its thickness and then go to Revit and model it, right? Because we don't have time. We have to model the thing and get approvals from the client so that we can then start fabbing it. So we'll model everything as if it's 3/4 inch or 1/2 inch plywood that we're planning on using, as if it's idealistically perfect at that thickness, right? And then we have a process downstream when we're in our CAM software where we're able to just adjust the tool paths a tiny bit, and we're designing our parts in a way where that adjustment doesn't screw them up so that we can make it to where everything will tab and slot together and have the tolerances that we need, and we can manage it over here where it doesn't take a ton of time to manage it. I'm not trying to make like fully intelligent parametric models over here in Revit that can change the thickness of all the plywood automatically. You see what I mean? Like, so it's like where are you managing that complexity becomes a huge part of the, okay, how's this gonna work as a workflow? And it's something that they don't talk a lot about in the like automated to digital fabrication stuff, you know? And there's a whole world like the CAM software. CAM software is the software that you use to set up jobs for the CNC machines. There's a whole world and industry of CAM software, right? And some of those tools have awesome features where sure you could model it in Inventor or in Fusion or in Revit or whatever, but it might be easier to just like fix that in the CAM software before you cut the part out, right? Like a great example for us is joinery on a CNC router. You can't get perfect inside corners on things because it's always being cut by a rotary cutter, so you always have a little radius. So you do a little bump out, little dog bone, they call it, where it's like coming at the corner and then it bumps over a little bit and then cuts. So you do a little relief, a little corner relief. And if you do those in the right direction, you can hide them in the joint. So when you put the thing together, you don't see them anymore, right? And I could model all those little bump outs in Revit or Inventor so that I have them. But our CAM software actually has a little tool where you can just click on a corner and it makes a bump out. And it makes it in the direction that you clicked, right? So I can just like make all my parts in Revit or Inventor or whatever, bring them into our CAM software, and I can just be like click, 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 and now I've got it, it's done. Send the parts, good to go, cut it out. So there's a lot of like little nuancy, fussy things that you're still doing downstream. This idea that like the designer is gonna make some perfect model and then from there on it's just gonna get automatically fabricated is never going to be true. So, other questions? Oh, there's gotta be more questions, come on. No? All right, there we go. Oh, making Teslas, yeah, yeah. Mm-hmm. Right, right. No, no, no. I think modular buildings are really interesting, but at the same time, for a friend of mine who works in the construction industry, I gave him a copy of it's a 1954 issue of Progressive Architecture where the title article is about how prefab is going to change construction. From 1954, right? So prefab is really interesting. What we focus more on, because we work in a very similar way, right? We're making these big chunks of the project and we're shipping out to the job site. But what we focus on is something, I think the problem with the prefab term is it's kind of too broad, right? There's this idea that we might make units in a shop and then ship them out to the job site and assemble them together to be a building, right? But if you're making those units using just like hammers and nails and you're not leveraging like digital fabrication or anything, then those units aren't really any smarter. And they might even be worse because things might not line up when it gets out on the job site because you have like progressive issues and tolerance issues and things like that, right? So, you know, if each module is just a tiny bit off, but you have 50 modules, by the time you get to the 30th module, you're like maybe a foot off of where you're supposed to be, and it starts becoming a big problem. And so, so I think that modular is really interesting, but I think what's probably more likely to happen is just the parts themselves will get smarter and smarter, and the work processes will get better and better. And it will be less about shipping like huge chunks of building places. But yeah, there's absolutely people doing like housing and other things. The problem is back to that chart that I showed with the 4 bubbles. Like prefab is really just focusing again on like just 1 or 2 areas of that, right? So like prefab modular construction has a really difficult time getting built in San Francisco purely because of the political reasons, right? Because there's a lot of like crazy rules about like when you're built, or in Oakland where we work, there's a ton of crazy rules. If you're building on a hillside, you have to follow all these special zoning rules about like setbacks and how tall things can be and where they are from the street. And unless you had some like perfectly flexible modular system, you're right back to like custom building to meet those rules. Or you're just putting a box on a site and the neighbors all hate it. So I do think that modular construction is really, really interesting. The thing I'm more interested in these days is, have you guys seen the automated timber framing for like mid-rise construction? So you're basically building like mid-rise buildings out of giant glue lams, right? So it's way easier to cut glue lams with a CNC machine than it is to cut steel, and they're making like 5, 10-story buildings like up in the Pacific Northwest just out of like glue lam timber framing, right? And all the parts show up labeled and all the parts, it's just like the steel industry, except it's way cheaper. And so I'm like, oh, that's really interesting because like, I would love to hire Connectex to help us build buildings, but none of our buildings really need a giant steel frame because we're not doing like hospitals and stuff like that. We're doing like goofy, weird, small stuff, right? Like that house and things. So, but if there was some system that I could tap into where I could leverage that kind of stuff, it'd just be awesome, right? So it's a great question though, yeah. Any other questions? There was a question here.
You mentioned the glue lam, you mentioned wood construction that you Any other materials that you experimented with?
Oh yeah. Yeah, totally. Here, I can go back really quick, I think. There's going to be a picture here. Let's see. Back to, nope, not that one, sorry. Thought it was in that one. Is it this one? Nope, not that one. Sorry, it's all the way back at the start of the work we do. There. We did a big project doing tons of folded sheet metal, right? So this was designed in Revit, rationalized out in Inventor to flatten it all out for the patterns. It was all cut on a water jet outside of our shop down the street and some in our shop by one of our CNC routers. It's all aluminum. It was all folded using a magnetic sheet metal brake, which is this awesome tool that lets us do really complex shapes like this. And so it was about 150 panels. Each panel was like yay big. They all bolt together to make this like undulating, like kind of ceiling that goes down the whole space. And this was one of those projects where commercial architect that does like big TIs in the Bay Area, and the client had this idea, we want this like fractal undulating ceiling, and they had like no idea what it was going to look like or who was going to do it. And so we did a bid, and we were able to do this. The price of this, I think this came in at like 20 bucks a square foot, 25 bucks a square foot, like installation included. I mean, yeah, right? Like, so when it works, it can work really well. So we've been doing more and more with folded sheet metal now because folded sheet metal is actually dirt cheap to make really cool stuff. So we've been doing more and more with that. But You know, you have to be really careful because like, you got to use something like Inventor or Fusion to do the unfolding. Like if we'd modeled this all in Rhino and unfolded it in Rhino, it'd all be wrong because Rhino folds everything as if it's infinitely thin paper, right? It doesn't actually do like K-factors and stuff unless you have a plugin that does that for Rhino, which they have, right? So I shouldn't talk too much smack about Rhino, but at any rate, like, you know, when we're doing something where there's like 10 of these panels bolting together, and if each panel's like 1/4 of an inch off, as I was talking before, like the 10th panel is going to be way off, right? And we, on this project, we 3D scanned the ceiling because it's an existing building. So we knew where all the sprinkler heads were, we knew where all the exit signs were and everything like that. And we were just able to design it so everything just fit around everything and just bolted into place. So yeah, so we've been doing more out of metal, more out of steel. There's some amazing tooling available for CNC routers now that lets you cut all kinds of crazy materials that you weren't able to cut before. So we took our older CNC router and we adapted it with like a misting system and a stiffer table, and like we're cutting mild steel, we're cutting stainless steel sheet, which I didn't think was remotely possible. You know, the tooling says it works on stainless, and we're like, all right, you know, and you put it in there and you like stand behind something over here while you start running the job, and like, and it totally works. Like, so we're doing more and more now with like crazy metal, because it's really fun. So yeah, no, good question, yeah. I mean, wood is just, I mean, part of the reason why so much of our stuff is plywood is because it's really cheap. You know, we do some stuff with, I don't think there's any, well, some of it's in this, but it's kind of hard to see in that top left project. We do some stuff using like salvaged hardwoods. So like the Long Now Foundation, the interval that we built, like the bar and a bunch of other stuff, it's all California black walnut that was salvaged from someone's backyard. Like, so local landscapers will fell something interesting, and our neighbors are Japanese carpenters that have a giant mill, and so we, you know, can like get it kiln drying, and then so we've made like big conference tables out of giant hardwood slabs and stuff that's like, oh, this is some local California pine that was killed off by the beetle infestation that's being caused by climate change, and you know, at least we can do something with it instead of it just all going to garbage. So so we work with a lot of different materials, because at some point in our process it doesn't really matter so much if like we're fabbing it in our shop or a shop down the street is fabbing it to some extent. So we're able to farm out stuff in certain ways. Like right now on that crazy house project up there, we're doing a very pragmatic like gutter system that's under that crazy glass wall thing. We're designing the ceiling in that, and then we're helping as kind of like a VDC on the project. So there's an architect and the client. We're not the lead architect on the job, but we're helping like this whole gutter system that's under that crazy sliding glass system is all stainless, and it's all getting made by a sheet metal shop in Richmond, California, off the Fusion models that I sent them. Right, so, yeah. All right, yeah?
Yeah, so earlier you said that you guys just do enough drawings to get permits.
Right.
And now, you know, maybe you're talking about complexity of some of these things.
Right.
So how does that work? There's just an old school drafter thought you got to document everything.
Mm-hmm.
How does that work when there's issues of contractor not knowing exactly what you want, or do you have special relationships with them so they'll do what you want? I mean, how does that
Right,
work?
right. You're absolutely on the right track. Part of it is that we're making drawings for the contractors that we're working with, but those drawings are more like assembly drawings. They're more like IKEA-like. We're doing a lot of like 3D cutaway views pointing out like this goes here and this goes here and this is how this works, instead of a bunch of like details or traditional shops, right? And also, we don't have to like spend a bunch of time dimensioning everything in our traditional, like in a traditional shop drawing process, because nobody's going to read that dimension to measure that part to then cut it out, right? It's all getting cut out by CNC machines. So we just need to make sure that the models are accurate for what we're doing, and then we know that downstream from that it's going to be okay, right? So I'm not worried about like doing a drawing of every variation of something. Like on this house project, there's a gutter system. There's this like floor trough thing that the HVAC comes up through, and so there's boxes in the slab where the air comes up, so there has to be a corresponding hole in the trough thing that holds the fancy grating that goes into the floor so it looks nice. And you know, we modeled every single one of those so that they all can, when they get to the job site, hopefully, fingers crossed, when they get to the job site, they just go where they need to go and nobody has to cut a hole in the field, right? But the drawing that we're shipping to the contractor is simply a plan view that shows number 205 goes here, number 206 goes here, right? And that's it. Because they know when they're on the job site, they're like, okay, these line up with the holes that are already in the slab, they just go down, they screw down, they're done, they put the next one in, right? So that end of it changes a little bit. The other thing is we we try to work with contractors really early on. Because we're also usually physically delivering parts of the project, we just have a lot more street cred. Like the contractors are actually willing to listen to us. And so when we were like, hey, we could do it this way, the contractors are a little more likely to be like, yeah, that could work. Because they know that we're in the same boat as them and just want to make the client happy. We just want to make money. Like, you know, we just want to do a good job. And so we try to tap into that, you know, fact. And if we can, we work with contractors that are more open to collaborating like that. But sometimes we still, even, there's a home builder contractor back in the Bay Area that we love to work with, but their insurance won't let us do installation on site alongside of them. Like they can be the only, like unless they hired us as a subcontractor under their umbrella, could we do any install? So we have to make stuff and hand it off to them to install, or wait until they're done and off site, and then we can come in and do installation, because they're not allowed to have anybody else there, and it's purely because of insurance reasons. So we have to kind of navigate and figure out like how are we gonna work together. So we try to talk to the contractors really early in the process, and even if we can, maybe bring them on for like pre-construction services and hire them as a consultant. And that's the other end of how we try to work. But some contractors, like the general contractor that was on this job, was a real curmudgeon. And I mean, he was a great guy, but he was just a really old school contractor. And he's like, where are you gonna set up to cut your panels so you don't make a mess I have to deal with? And I was like, we're not gonna have to cut panels. And he's like, no, F you, you're gonna have to cut panels. There's no way you're gonna do this without cutting panels. I was like, no, we 3D scanned the ceiling, we fabricated everything. We're not gonna have to cut any panels. And out of the, I think there was like 200 and something panels at the end of this. 3 of them didn't work because somebody put an emergency light where it happened after we'd scanned and it wasn't on the drawing set. You know what I mean? So like, you know, sometimes we just have to basically be like, it's gonna work. It's not your problem anyway. Like if it doesn't work, it's on us, you know, to the contractor, so yeah.
For you specifically, it works just having enough drawings to get permits because of what you do and how you prove them, but it wouldn't necessarily work for anyone else.
Which is that type 4 automation I was talking about, where it's like, okay, in order to do certain things, you might have to fundamentally change your whole business. There you go. Like, I mean, when I go and talk to friends of mine that still work at like Gensler, where I used to work, and they ask the same question, like, well, how could we work this way? And I'm like, I don't know, I'm sorry. like it's a totally fair crit that like our thing works well in our little niche that we're doing. Yeah. We worked our way into it, and we theoretically accept more risk than most firms would be willing to do, because like we're on the hook to deliver this stuff, and we could eat it if it doesn't work out. Now, ironically, pragmatically, we have less risk because we have more control, and we have more opportunities to fix problems before they become such big problems that people want to sue each other over stuff. Like if one of these panels, when those 3 panels were wrong, instead of having to go argue with a subcontractor and argue at whose fault it was or whatever, I'm like, those panels cost, like that aluminum, we got it like 4 foot by 12 foot long sheets of it for like $40 a sheet, right? So I'm like, okay, we can make 3 more panels. It's gonna cost us a couple $100s to make those in terms of materials and labor and powder coating and whatever. We'll just go make 3 more panels that fit, and the client will be happy, and everything will be okay, and the, you know, like, do you see what I mean? Like, yeah, so it's just figuring out how to make it work. Yeah. But it's a great question, thank you. Yeah, thanks you guys. I'm still around, I should turn off. Oh, thank you. Yeah, let me hear.